Welcome to Lecture 18, 2.8, Algebra of Functions and Function Composition. So we're going to be working a lot with functions. Alright, so the first objective is performing operations on functions. Okay. So this is when we're working with two separate functions and finding ways to sort of combine them together. So one of the first operations is called the sum of functions. And it's an interesting notation, but just practice it and you can get used to it. So what we have is a notation like this: f plus g of x. So once again, this is read as f plus g of x. And this is going to equal to f of x plus g of x if you have two functions. And generically, we are calling them f and g. So that's the sum of functions. Why sum? Because we have addition going on. The next one is difference of functions. So very similar to sum, except this time we have a subtraction. So this is read f minus g of x. This will equal f of x minus g of x. Pretty straightforward so far, I think. Next we have the product of functions. So what is product? That's multiplication. So if you have f times g of x, that'll equal f of x times g of x. Alright, and so we have our multiplication symbol going on. And lastly, we have the quotient, or fraction, also known as division. So f divided by g of x equals f of x divided by g of x. And we have that division going on. But there is a special requirement for the quotient of functions. Notice we're dealing with a fraction, and as usual, you can't have a 0 in your fraction's denominator. So this is where g of x cannot equal to 0. So it's a small thing to keep in mind. And there we have the operations on functions. Let's take a look at example 1. Given the functions f of x equals 2x squared plus x, and g of x equals 3x minus 5, as well as h of x and k of x, find the following. So the first one, we're given f plus g of x. Well, if I write this out again, this is f of x plus g of x. Now, what is f of x? F of x is this value right there, and g of x is that value right there. So I'm going to go ahead and plug those in. So f of x plus g of x, let me just keep the color coding going on for now, x squared plus x, 3x minus 5. Okay, let's drop the color code, so 2x squared plus x plus 3x minus 5. Now we can combine the like terms of the x's, and we have 2x squared plus 4x minus 5. Alright, I didn't leave the most room, but let me go ahead. We would write, let me rewrite this down here because I have a bar here that I can't write on. F plus g of x is equal to 2x squared plus 4x minus 5. And there we go. Now let's take a look at f minus h of x. Well, we're introducing h, so let me go ahead and introduce that. Alright, so we have f minus minus h of x, and f is the red value, and h is a green. So I'll go ahead and input those. F of x is the same thing we used last time, so 2x squared plus x. H of x this time is that radical, x plus 4. So now we have 2x squared plus x minus the square root of x plus 4. And looking at this, none of these terms can add. So that's it. So we're left with f minus h of x equals 2x squared plus x minus the square root of x plus 4. That is the most we can do for simplifying it. Now let's take a look at next one, C, h times k of x. So h times k of x can be rewritten as h of x times k of x. So we have a new value, k of x, right there, it's the fraction. And then we have h of x, which was our green. Now let's go ahead and input them to the equation. And h of x was the radical, square root of x plus 4. and k of x was the fraction, 1 over x. This is going to equal, let's see. Well, I could put this over 1, which means I have the square root of x plus 4 over x. And that's all I can do to simplify. So to end this, I'll rewrite it and box my answer. And we're done, because that cannot be simplified. And lastly, we have the quotient. Alright, so this is going to equal f of x over k of x. And f I had in red, and k was in yellow. So that's going to equal, let's see, f of x over k of x. F of x is 2x squared plus x, and k of x is 1 over x. Ooh, look at that, we have a complex fraction going on. But I can go ahead and rewrite this. It's that amount divided by the 1 over x, and then take the reciprocal. Oh, that was an ugly line. Take the reciprocal. So 2x squared plus x over 1 times the reciprocal of that value. Let me change the color for that. Times the reciprocal, which is going to be x over 1. Multiplying out, we had, let's do this. X times 2x squared plus x. Then we can distribute in the x value. And we'll get 2x cubed plus x squared. So my answer is f over k of x equals 2x cubed plus x squared. Okay. I've always sort of found it fun using those. Now let's take a look at example 2. Once again, we are given these functions, and we're told to find the following. So notice, this time, instead of x, we have actual numbers going into our equations. So changing the game up a little bit, but it's a pretty similar concept. So f plus k of 2. This is going to equal so f of 2 plus k of 2. Actually, let me rewrite that on the other side. Give myself a little more room. Okay, so f of 2, what does that mean? Well, wherever I see a 2 in f, wherever I see an x in f, I'm going to replace that with 2. So this will be 2 times 2 squared plus 2. That was my f value. Then I'm adding to it my k value. And k was 1 over x. So 1 over, and we're replacing the x in k with a 2. Okay, so it does take a moment to get used to the notation. Go ahead and take the time to pause the video and figure that through. Okay, so this was the f inputted, and this is the k inputted. Alright, so simplifying this out, we have 2 times 4 plus 2 plus 1/2. That'll be 8 plus 2, so 8, 9, 10, plus 1/2, which will be 10 and 1/2. So, f plus k of 2 is going to equal 10 and 1/2. Now let's look at f minus h of 5. So this would be f of 5 this time minus h of 5. Once again, we're replacing the x values with 5. So 5 is replacing in here. And then for h, we're replacing that value with 5 and inputting it. So f is going to be 2 times 5 squared plus 5 minus the square root of 5 plus 4. Let me just color code that to show where they went. Alright, let's go ahead and simplify. That'll be 2 times 25 plus 5 minus the square root of 5 plus 4, which is 9. 25 times 2 is going to be 50 plus 5 minus, and the square root of 9 is 3. Okay, so simplifying across, we'll get 55 minus 3, which is going to be 52. So f minus h of 5 equals 52. And let's see, we have 2 more to go. H times k of negative 3. Okay, so h of negative 3 times k of negative 3. This time we're replacing x with the 3. So k is, we used yellow, so we're going to replace it there. And then h we used blue. So let's go ahead and input the functions. We have the square root. So notice I'm using these brackets to indicate where I input them. You don't need to use the brackets. I just like to use them as sort of placeholders. So negative 3 plus 4, that was my h, times my k value, which is 1 over, and we're replacing the x with a negative 3. Once again, let me just go ahead and color code that. Hopefully the color coding is helping. So the square root of negative 3 plus 4 is going to be the square root of 1 times 1 over negative 3. Well, the square root of 1 is just 1, so 1 times 1 over negative 3 is just going to be 1 over negative 3. So we get negative 1 over 3, and then we have h times k of negative 3 equals negative 1 over 3. One more to go. G over k of 0. So this breaks up into g of 0 over k of 0. And so we're replacing x this time with 0. So g, we haven't used g yet. I'll use green for g. That's where we're replacing the 0. And then k of 0, we've already used that before with yellow. So when I plug these in, I'll get g of 0, so it's going to be 3 times 0 minus 5 divided by k of 0, which is 1 over 0. Interesting. Oops, wrong color. So, even if in the numerator it worked out okay, so we had the 3 times the 0, which would be 0 minus 5, we still have that 0 happening in the denominator for our first fraction. The answer for this, you would just state undefined, because we're dividing a 0 in the denominator of our fraction. Alright, so let's look at example 3. Given g of x equals negative 3x, h of x equals x squared minus 9, and this should say k of x equals x minus 1. Find the domains of the following and answer in interval notation. So the first thing we want to do, because we're talking about finding the domains, I'm going to first indicate what the domains are. So let's look at g of x first. That is a linear equation. Do we have any restrictions on a linear equation? The answer is no. Any number is okay in a linear equation. And real quick, how did I know this was linear? Because looking at our variable x, the power is to the 1, so it's only linear. Alright, so the domain for g of x is just negative infinity to infinity. Now, what's the domain for f of x? Oh, not f, we're using h. Well, looking at h, what kind of an equation is it? It looks like it's, Oh, we have the square there, so it's quadratic. Well, are there any restrictions on quadratic equations? And the answer is no, there are no restrictions. So once again, our domain for h is negative infinity to positive infinity. So we're not going to have too many problems when we actually try to find the domain of the subtracted answer. But let's go ahead and write this out. I'm going to get a little more space down here. So g minus h of x, that's going to equal g of x minus h of x. So g is in the blue, so that's negative 3x. Subtracting from it h of x, which is yellow, x squared minus 9. Once again, I'll color code that to help. And that minus just followed down. So then combining any like terms. Well, there are no like terms, so we're just left with negative x squared plus 9 minus 3x. Now, to find the domain, you're going to take the intersection of the two domains. So let's go ahead and graph this. The domain for g of x, I'm going to color code that with blue. Domain for h is going to be yellow. So for g of x, our domain is all real numbers. And then for h of x, our domain is also all real numbers. So the intersection of these is all real numbers, which means that the domain of g minus h of x is also going to be all real numbers. So once again, we looked at the intersection, not the union. And since we asked for two different things, I'm going to go ahead and box the two different answers that I have. So now let's look at b. G of k of x. So k of x, we haven't found the domain of that, so I'm going to go ahead and write that up here. The domain of k of x. Ooh, k of x is a radical. So let me go ahead and find that on the side here. What number are we not allowed to have there? Well, we know for radicals, the item inside, so this is going to be my scratch work, the item inside needs to be greater than or equal to 0. So x minus 1 needs to be greater than or equal to 0. Solving for x, we get that x needs to be greater than or equal to 1. If I was to graph this out, my x values need to be greater than or equal to 1. So interval notation, that's going to be 1 to infinity. Alright, this was all my scratch work for the domain of k. So 1 to positive infinity. And we're going to use red to indicate k. Alright, let me go ahead and erase my scratch work. And let's find g times k of x. Alright, so this is going to be written out as g times k of x equals g of x times k of x. I'll go ahead and color code these as usual. So k is in red and g is blue. So that's going to be g of x is negative 3x times my k of x, which is the square root of x minus 1. And once again, color coding. And, you know, we really can't do much with these guys. They don't really multiply out. So that's all we can really do. So I'll rewrite this. And the last thing we need to do is find the domain. So we'll take the two domains and find the intersection. I'll go ahead and graph it. Let's see. The domain of g is negative infinity to positive infinity. And that I'll graph in blue to keep with the color coding. Now the domain of k, ooh, it's different. We have 1 to infinity. And we include 1. Alright, and remember, we're talking about the intersection whenever we're looking at combining these together. So where do they intersect? They intersect along here, from 1, including 1, to infinity. So the domain of g times k of x, which was the intersection of the two domains, g and k, gives us 1 to infinity. And we box this answer as well. Now let's take a look at the last one. We have k divided by h of x. So this is going to be k of x divided by h of x, and let me go ahead and color code this. K is in red, and h is blue. Alright, k is the square root of negative 1, square root of x minus 1, and h is, h was not blue, h is yellow. Let me erase that real quick. And h was, what's the function for h? X squared minus 9. Okay, there's really not much we can do with that. We can't really simplify those guys. So that is that. So k over h of x. Now what we need to do is find the denominator. However, there is a very small trick in this one that was different than the top two. And the problem comes into the fact that we are now dealing with a fraction. Fractions always give us problems. Remember, we can't have 0 in the denominator. So x squared minus 9 cannot equal 0. We need to take those values out. So let's check that on the side. We know that x squared minus 9 cannot equal 0. So solving, we get x squared can't equal 9. Square rooting both sides. We get that x cannot equal plus or minus 3. Why did we do that? Because we have a fraction and we cannot let the bottom item equal 0. Alright, so with this new piece of information on hand, let's go ahead and graph the domains for k and h first. So the domain for k was 1 to infinity, including 1. And then the domain for h was all real numbers. And we want to take their intersection. So the intersection of these two are all of these numbers here, except we need to take into the fact that we found out that we're not allowed to have plus or minus 3 in our equation, or sorry, in our domain. So negative 3 we can't allow. We'll take that out. And positive 3 we can't allow. We'll take that out. Well, looking at the intersection and taking out 3, we go from 1 until 3, but we can't include 3. Then we start again after 3, and we go on to positive infinity. So now you might wonder why we don't include this half. Well, it's because we're looking at the intersection, and that negative 3 just happens to fall in the half we're not using. Alright, and that's the domain. So we have the domain of k over h of x. Right there. So once again, if you have fractions, just be careful because you can't have the denominator equal to 0. So now let's take a look at objective 2, evaluating the difference quotient. So the difference quotient kind of comes from the average rate of change, which we looked over in 2.4. Also very similar to the slope. So the difference quotient is f of x plus h minus f of x divided by h. If you're given a function f of x, just generically f of x. So the main thing to notice here is you're using f twice, you're subtracting it, and then you're dividing by h, which is not a function. Okay, so careful, that's not a function. The only two functions are f there and there. And the other thing that's happening is you're inputting x plus h in place of x for one of them, but then keeping x the same for the other. So it's a little interesting. Let's go ahead for example 4. So finding the difference quotient, f of x plus h minus f of x divided by h is going to equal, well, f of x plus h, what are we doing here? We're replacing x with x plus h. So inputting that, that's going to be 2 times, remember we're replacing that with x plus h, then minusing 6 from it. And this item came from the f of x plus h. Then we'll take the subtraction. Oops, wrong pen. We'll subtract, just color coding here so you can keep track of where everything is, f of x. So f of x is just going to be what it was before, 2x minus 6. And then dividing that all by h. Okay, so this whole big thing here came from the f of x plus h. And then the f of x, we just copied down again from there. Now simplifying. Let's go ahead and distribute this in. So we have 2x plus 2h minus 6. And we'll distribute in that negative there, minus 2x plus 6 divided by h. Let's simplify what's on the top. The 2x's cancel, and then the 6's cancel. So we're just left with 2h and h. So 2h divided by h, the h's cancel, and we're just left with 2. And that right there is our answer. That is the difference quotient. Now let's take a look at f of x squared minus 3x, and we're going to find the difference quotient. So once again, the difference quotient is f of x plus h minus f of x all over h. So for f of x plus h, what are we doing? We're going to replace x with x plus h. That looks strange. So let's replace that. So we're going to take x plus h and square it. And then we're going to subtract 3 times the x plus h. Alright, so this whole thing has now become right there. That 3 is the 3 from there. The square is the square from there. We're just squaring the x plus h value. So just squaring it and then multiplying it. And then we'll go ahead and plop in the f of x, which is pretty simple. We already have that right there. X squared minus 3x divided by h. Let's see, simplifying. Okay, I have to FOIL that out, so it's going to be x plus h times x plus h minus 3 times x plus h. And then I'll go ahead and distribute that negative in, so that'll be negative x squared plus 3x. So I'll FOIL this out. That'll be x squared plus 2xh plus h squared. Then let's go ahead and distribute that negative in, the negative 3 in, which gives me negative 3x minus 3h. Bring this down. We get the negative x squared plus 3x. So one thing to note, all of this came from the f of x plus h. And then these values came from the f of x. And we had that minus sign that got distributed. Hopefully the coloring is helping and not throwing you off. Now let's combine like terms. The x's cancel. X squares cancel. And in the top we're just left with 2xh plus h squared minus 3h divided by h. Now notice, in the numerator they all contain h, which means we can factor it out. So factoring out that h, we are left with this, and then we can cancel the h's, which means our final answer comes out to 2x plus h minus 3, which we cannot simplify. And that is our answer. So the difference quotient does give some students a hard time, so if you need any further clarification, please send me an email and we can set up a Google Meet to go over this. Now for Objective 3, compose and decompose functions. Please note, we do not cover decomposing functions in Math 103, just composing. So for composition of functions, the composition of f and g, denoted f, and notice this says of. It's not the multiplication symbol. The multiplication symbol would be filled in. This is open. So f of g is defined by f of g of x is equal to f, and you're inputting inside of it g of x. In case it's weird, so you're taking one function and you're sort of stuffing it into another function. So if you think of f and g as boxes, you're taking the box f, and you're going to take the box g, and you're going to stuff it inside a box f. So you're taking one function and inputting it inside of another function. So instead of just a number this time, you're playing with two functions. So let's take a look at some actual applications. Given f of x equals x squared minus 5 and g of x equals x plus 6, find the following. So for A, we have f of g of x And what we want to do is take f, and we're going to input into it g of x. And notice I make the parentheses really noticeable and big because I find it makes it a little simpler or a little easier to look at. So we're going to go ahead and put g of x in, which is x plus 6. So this is going to be f of x plus 6, which then means wherever we see x in f, we're going to replace it with x plus 6. So we get x plus 6 squared, and then we add or subtract 5 from it. Let's FOIL that out. So we have x squared plus 12x plus 36 minus 5. We can add those together and we get x squared plus 12x plus 31. And that right there is the composition of f and g. Interesting? I find these ones kind of fun. All right, let's do the next one. If you want to, go ahead and pause the video and try part B by yourself. Okay, so for B, we have g of f of x. So this time it's the switch. We have g on the outside, the big box, and we're going to input f of x into it. So I'm going to go ahead and color code f of x with yellow. We're going to switch that out. So that's going to be g of, and f of x was x squared minus 5. Now for g of x. Wherever I see, alright, so then inputting this, I'll get x plus 6, so I have my x value, which I'm replacing with x squared minus 5, and then I'm subtracting from it, or I'm adding, to it, a 6. So then x squared minus 5 plus 6, we can simplify that to x squared plus 1, which means that g of f of x equals x squared plus 1. Now, example 7, which I believe is the last example. Yep, this is the last example for this page. Given k of x equals 7x minus 2, and h of x equals negative x squared plus 2x, find the following. Ooh, so notice this time we have numbers going on instead of just x. Upping the problems. Okay, so what should I do first? Well, h of 2. I'm going to rewrite this problem so it looks a little easier. So we're taking k and we're inputting into it h of 2. Well, h is negative x squared plus 2x, and we're going to replace x with 2. So this is going to equal k of, and then we have negative x squared plus 2 times x, and we replaced that with the 2 values. Okay, so that's going to be k of, and I'll go ahead and simplify this, so that'll be negative 4 plus 4, which is going to equal 0. So then we have k of 0. And k of 0, we're going to input 0 there by the 7 in place of x. We get 7 times 0, and then minus the 2. So 7 times 0 is 0 minus 2, which is negative 2. Which means k of h of 2 is negative 2. Go ahead, try part B by yourself and check in with me in a second. Alright, so part B, notice I set these up differently. One of them started with the original definition of composition, the other one sort of skipped a step. And a lot of times in books, both options will be presented to you. Some books choose to give this, other books choose to give that. So it's good to know that they both exist. Alright, so h of k of 0 is going to be h of k of 0 and k of 0. That's going to be the 7x minus 2 and inputting 0 in place of x. So let's see, we'll have 7 times 0 because we're replacing it with 0. And then we have h of, so 7 times 0 is 0 minus 2, so negative 2. And now we're replacing x with negative 2 in h. Then we have negative 2 squared plus 2 times negative 2. Replacing those values with the negative 2. Simplifying, we have negative times the 4 minus 4, which gives us, negative 8. So, h of k of 0 is negative 8. Alright, that is it for this section. Please email me if you have any questions with the assignment.